In this section, we're going to look at the modulus and argument for a complex number. Starting with the modulus. The modulus of the complex number z, which is a plus bi, is given by the modulus of z is equal to the square root of a squared plus b squared. This is just Pythagoras' theorem, as we'll look at below. So let's suppose we have the complex number z, which is 3 plus 4i. So we would represent that on an Argon diagram like so. So here is z, and the point represents z, and then we have the vector from the origin. Essentially, the modulus of the complex number is the length of the vector. And we know that this is going 3 across and 4 up. You may spot the 3, 4, 5 triangle because, of course, this is a right-angled triangle. But we can see that the length of the vector is just going to be the square root of 3 squared plus 4 squared. Now, while we're here, let's just think about the conjugate, which is z star or sometimes z bar. That would be 3 minus 4i. So if we draw that, so that would be here, note that z and its conjugate are always reflections of each other in the real axis. And of course, the modulus of z bar would also just be the square root of 3 squared plus 4 squared, or negative 4 squared if we're being strict, but of course negative 4 squared is exactly the same as 4 squared. And so we can see that mod z would be equal to mod z star.